Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss introduction to alternating circuits and alternating current. How Kitsofs law is used for alternating currents and basic idea towards resistance, reactance, impedance and admittance. Let's begin. An alternating current is one which changes in magnitude and direction periodically. Here in alternating current circuits, we are consider that the current and voltage oscillate simultaneously without any change in amplitude. And to produce an alternating current in a circuit, we can use generally a dynamo or an electronic oscillator which creates an alternating current to the circuits that is used as the source of an alternating current. Okay. Look here, this is the EMF, it is the time. So the graph represents sinusoidal curve. We represent that EMF in terms of sine or cosine function. Here E naught, that is the peak value of EMF. Similarly, for current, I T, this is the peak value, that is I naught, and EMF and current are given the instantaneous value. So the instantaneous value of alternating EMF at any instant, the instantaneous value of alternating EMF at any instant t is given by that E is equal to E naught sin omega t. Here we represent that EMF in terms of sine function or cosine function. Look here, that can be written as Im. Im referred as the imaginary part of E naught e to the power I omega t. Why we write this type of notation here? As e to the power I alpha is written as cos alpha plus I sin alpha. Here cos is the real part, that is the real part, that be the imaginary part. Imaginary part. When we write real part of e to the power I alpha, that is cos alpha. If we write imaginary of e to the power I alpha, then it will be written as that particular part sin alpha. Okay, the imaginary of e to the power I alpha with the sin alpha. In this way, e naught sin omega t is written as imaginary part of this term e to the power I omega t. So, the imaginary part will be sin omega t. Here, as we say, I m represents the imaginary part and I be the imaginary number, where I is the imaginary number. We know in case of complex number all these things, which is equal to under root of minus 1 with I. And the terms like E naught is the peak value, or we can say the maximum value of alternating EMF. Omega, that is the angular frequency of alternating EMF, angular frequency of alternating EMF, which is equal to 2 pi nu. Nu be the frequency of alternating EMF, where nu frequency of alternating EMF and is equal to one by time period, which is equal to 1 by t. T be the time period of one oscillation, where t be the time period of one oscillation. That is the representation of an alternating EMF. Similarly, an alternating current can be written. These are the terms. Next, can we apply Kitsof's law for AC circuits? We apply generally Kitsof's law for DC circuits. There are two laws proposed by Kirchhoff, named as Kirchhoff's first law, as Kirchhoff's current law, Kirchhoff's current law, named as KCL, and Kirchhoff's voltage law, Kirchhoff's voltage law, that is known as KVL. So, in case of DC circuit, that Kirchhoff's current law, basically the statement of conservation of charge, that is the conservation of charge. Look here, in DC, that is the time independent current circuits, that steady current which does not depend upon time. So, the statement of that Kirchhoff's current law here is the sum of currents, the sum of current at a point, or we can say that is the node or junction, that is known as the node or junction in a circuit is 0. Look a figure here, let that is the point I1 current entering, I2 current entering, I3 current entering. That particular point is known as, that point is the node or junction. So, the sum of these currents, that is summation over I, is equal to 0, or we can say I1 plus I2 plus I3 is equal to 0 here. Means currents towards that point is taken as positive. If a circuit there will be the current from that of point, then it will be taken as negative. Let we take a circuit here where current I1 enters, current I2 enters and I3 exists. At that of case, I1 taken as positive, I2 taken as negative, I3 taken as negative is equal to 0, or I1 is equal to I2 plus I3. So, I1 current, look here, that I2 be outward direction, so it will be taken as negative. Then we apply that Kirchhoff's current law. In that point the current is divided. In that of case of DC, the charges cannot accumulate in any volume. Therefore, I1 current here not accumulate and divided into I2 and I3. But in case of AC current, there will be the dependence upon time. What happened here? The charges tends to accumulate temporarily at various points in that of AC circuits. How the accumulation takes place? Take an example. In case of conductor, when that conductor is placed inside that of electric field, the charge accumulates temporarily. Similarly, in case of AC circuits, charge accumulates temporarily. But if the frequency of AC in such that time scale variation of current is much greater than the time scale accumulation of that of charge in that of conductor, then we assume that there is no accumulation of charge in that of conductor. Here in case of AC circuits, if an capacitor is connected to an AC circuit, exactly what happened here, then the charges do accumulate an equal amount of accumulate due to the current changes with time. This means here positive charge, here negative charge accumulates. This means whenever charge is deposited on one plate, an equal amount of charge flows out of other plate. Hence, as long as current enters one plate, the same current is leaving the other plate of that capacitor. Thus, two plates of the capacitor are just like the two ends of the resistor. So, that is similar to that figure can be similar to act as two ends of a resistor. So, here we can easily apply Kirchhoff's first law for that of AC circuit containing a capacitor. Like this sense, Kirchhoff's current law can be applied in case of AC circuit. Kitsofs KCL is applied in AC circuit. Okay. Can we apply Kirchhoff's voltage law in AC circuit? Look here, it is basically the statement of conservation of energy, that is the conservation of energy. What exactly be the statement in case of DC? That is the statement in DC. In DC, that is the statement. Again here in DC, what will be the statement of Kirchhoff's voltage law? Look here, in DC, for any closed circuit, or in technically we say it as the mesh, the algebraic sum of potential drops across resistors is equal to the potential drop across the battery, that be the statement of Kirchhoff's voltage law in case of DC. Look here, in case of AC, as we say, that is the time independent current. So, if inductor and capacitors are present in AC circuit, what happened here? If we draw a circuit like this, where a inductor, a capacitor and a resistor are connected series with that of a AC source, that is a inductor, that is a capacitor, that is a resistor, and here we apply the EMF E naught sin omega t. Look here, in most of the AC circuits at ordinary used frequencies, and the time required to propagate the electric field through the various elements of the circuit is very small as compared to the time constant of that circuit. Hence, the current and potential difference have instantaneous relationship. Therefore, we take the instantaneous voltage and current at their terminals. Hence, the situation in AC is very similar to that of situation of DC. So, here the current be the instantaneous current, and again here the current be the instantaneous current as the function of time. The accumulation of charge is the function of time. Now, Qt be the charge on that of capacitor at that of instant, E be the potential difference across that source at the instant. So, according to Kirchhoff's law, here the Kirchhoff's law can be applied. E is equal to, applying Kirchhoff's law, Kirchhoff's voltage law. So, E is equal to potential at inductor plus potential at capacitor plus potential at a resistor, or E is equal to potential at inductor, that is L d I as a function of t by dt, plus potential at capacitor, that is q by c, plus here the potential drop, resistance into current. In this way, we apply Kirchhoff's voltage law in an AC circuit. So, Kitsofs law can be applied AC circuits, both Kirchhoff's voltage law and Kirchhoff's current law. Now, a basic idea towards resistance, reactance, impedance and admittance. Look here, when a resistor is connected to a circuit, resistor connected to an AC circuit, so the resistance means the opposition provided that resistor to the current is known as the resistance. Here the opposition provided to the current by the resistor is known as resistance. Okay. Same thing, when capacitor and inductor are connected to that of AC circuit, then it provides an opposition to that of current, and that opposition is known as the reactance. Look here, when a capacitor or inductor is connected to a circuit, it provides opposition to current. That opposition is known as reactance. In case of capacitor, for capacitor that is capacitive reactance denoted by Xc. For inductor, that is inductive reactance that is Xl, either C or L or both when connected to that of circuit. Look here, either C or L, not both, either C is connected or either capacitor is connected or inductor is connected. Then the opposition provided to that of current is known as capacitive reactance or inductive reactance. If these three means resistor, capacitor and inductor are connected series to that of AC circuit, then the opposition provided to the current is known as the impedance. The opposition when resistor, capacitor and inductor connected to inductor connected parallelly to an AC circuit, it provides opposition to current. That opposition is known as impedance. That opposition is known as impedance. And it is denoted as Z be the impedance, Z be the impedance. So, the total opposition means the total potential drop to that of current. Next, admittance. Admittance is the reciprocal of impedance. That is Y is equal to 1 by Z. Admittance is the reciprocal of impedance. So, here we know the basic idea of resistance, what is reactance. For capacitor it will be capacitive reactance, for inductor it will be inductive reactance, and impedance and admittance. So, with the help of this video lecture we understand introduction to AC circuits and alternating current, how the instantaneous value of current or voltage can be given, and the terms. Can we use Kitsofs law in case of AC circuits, that is the reason how Kirchhoff's current law and Kirchhoff's voltage law can be applied to an AC circuit. Then and basic idea towards resistance, reactance, impedance and admittance. So, with this useful and informative notes, let me wind up this session. Thank you.